been trying to get onto this for some weeks. One of the viewers, Eddie in Northamptonshire, very kindly passed on to me some scrap CB radios. So we don't like to use sets for scrap which are in one piece, unless when we open them up there's no alternative. I'm just digging out a microphone. It's got a short power lead, so I'll be able to connect it up to those crocodile clips I have on my bench that I enjoy shorting out. Yep, they still short out nicely. So we've got a short bit of lead we can deal with, because the trouble with these is the connectors which were originally there long disappeared. Right, well, I'm going to open it up first because we don't know whether there's anything inside it, although it's got some weight to it. So I will just pause the video while I take 4 screws out. What I didn't say is what it was, and it's a Mustang CB2000, which is a Cybernet 002F chassis. The same chassis is used in the genuine version of the Amsrrad 900 and the Amsrrad 901. So a jolly good performer. Now it's certainly been through the wars, and we may be putting it through the dishwasher if it turns out to be repairable. Well, straight away it's had lots of soldering around the phase lock loop department. But it doesn't seem to. It seems to have got the ballast resistor still in place, so it hasn't had the kiss of death, which seems to happen to these. And it hasn't got any mashings up around the phase lock loop. So I mean that looks a genuine set. So I think our best course of action is to get the isopropyl alcohol around there, and then I'll get there with the magnifying glass and just see if there are any issues. Now, are we going to use Mr. Chippy's toothbrush, or are we going to use the proper RS brush? I think we'll use the proper RS brush. You see plenty of Mustang 1000s, but you don't see many Mustang 2000s. It's even worse when we actually bought some scrap chassis, and amongst them, oh, that's Fidelity 2000. Amongst them was a Mustang 3000, which are even more difficult to come by. So I'm just going to have a closer look at that. Well, I've switched it on. It's lit up on channel 19, and the meter hasn't lit up. Oh, it transmits as well. Well, that's not bad for a scrap set. I'll just set the frequency counter, set the signal generator for channel 20. Oh, that's interesting. It's stupidly off frequency. Now how can that be? Select channel 9. Let's see what happens. That's correct. So on channel 14 it's receiving channel 20. Yep, channel 14 is channel 20. So we do have a channel selector switch problem, which could be why they've been soldering around that area. I'll have a look and see if I can see a dry joint. Okay, so it's now receiving channel 20 on channel 20, and it's now transmitting channel 20 on channel 20. So I will just check channel 1 and channel 40. 60125 for channel 1, 99125 for channel 40. So I just simply replaced the face lock loop chip, the LC7137. You can end up with a blown data line, usually with a static problem, you know, if the vehicle's been hit with static electricity somehow or whatever, but that's usually the problem. And it's my own set, we're just doing this for a bit of laugh, and I've taken one off a scrap chassis, and the scrap chassis which I used was an LCL Economy, which we bought in as a scrap chassis, so it's already came with lots of parts missing, so it wasn't going to be resurrectable without a case either. What I'm going to do, I'm going to take a break, and while I take a break I'm going to put these case parts through the dishwasher, because the radio is obviously now a goer, so it's worth spending that bit of time now on. So we'll get the knobs off it, and we'll take the chassis off it, and it certainly needs a good clean up, so that's what it's going to get. So I'll see you in a bit. So fast forward a bit, and we are now in a position to start tuning the transmission and all that. So I think the first thing we'll do is start with the VCO, and we'll take that camera back off before we even started. Switch the radio on, and try and turn the shaft without the knob on it, which is quite novel. So we now have channel 20 where it should be. I'll just widen this so that you can see the meter a bit easier. So the chassis is floating on these, so we need to put that on earth, so I'll just put that on the crocodile clip that I like shorting out, and it's the far side of this green capacitor. And I'll tell you what, we do this on channel 40. What am I doing it on channel channel 20 for? Just walk across the room and get the notes. Get there the notes for the Cybernet 134. Right. So it is whatever it says. Doesn't matter how many of these I do, I can't remember. So it's between capacitor 9 and ground, set to channel 40, set to transmit, and check this between 4 and 5 volts. So I'm going to transmit now, Well, 3.99. Tell you what, if you weren't watching, I wouldn't have moved that. But because you are watching, there we are. I've adjusted it to 4.19, and that's with the coil just there. So now we move it to channel 1. Well, I don't know why I went all the way around. And it needs to be somewhere over 2.5 on transmit and receive, which it is. So we haven't had to adjust the trimmer capacitor there, which would have had to adjust if the receive had been out. So that's the VCO, and if you don't do the VCO and you don't check the VCO, that's when you start losing channels. Like, you know, you can get a radio which doesn't transmit above channel 37 when it's cold, and silly mistakes, silly faults like that, and it's always the VCO. And that's what gets overlooked. So the transmit lineup starts here. Transformer 2, Transformer 3, Transformer 4, the one with the wax on it, and the one at the end. Always check that ballast resistors are there. We get people who short them out because their good buddy meters say they're doing 1,000,000 watts when you short that out, but they don't do that, and what they do, they don't do it for very long. I did once see 7 at, you know, it's like we have that Rotel 230. It's not just any Rotel 230. Out of the dozens I've seen over the years, that particular one just received so well that I kept it as our test sample set. Right, so I'll put that camera back. We've got a dead cheap pan and tilt head on that camera now, and the camera's twice the weight of what the pan and tilt head's supposed to do. So that's going to last a long time. Okay, so we're on the 3 watt scale, and at the moment we are doing 2.5 watts. So just make sure we've peaked that one. Move up to the next one. Hope somebody's got a channel knob to sell me, because I'll tell you what, taking the channel knob off, which had been glued on, and it's come away in 3 pieces. So anyone got a Mustang channel knob for a 1000, 2000, 3000, send me an email, please, and I'll buy it off you. No, that didn't get heated enough to move. Let's try again. That's right at the end of its travel. I'm just go the other way with it. Right, I'm going to pause the video. I'll just go through those a few times to get absolute optimum. We're doing about 3 watts at the moment. Okay, we've now got 3.5. There's a good 3.5 there. It's on the 4 watt scale. And I just did a schoolboy error. The last thing I was doing was a walkie-talkie, which is 12 volts. The power supply was still set at 12 volts. So I've brought that up to 13.8, which brought the power up 0.5 watt straight away, just like that. I have retuned it, and everything's hunky-dory, as they say. So let's look at what the power meter says. I'll take that camera off, we don't need that. So it should be the centre of the red zone, and it's towards the upper end of the red zone, so I just need to adjust that. So that is RV1, which is just there, centre of the red zone. Out of interest, I'll just see what low power does, which isn't adjustable on these radios. I'll just bring that camera back as well so you can see. Oh, what's that about then? Didn't I press it? Oh, that's better. Oh, 0.25, should be 0.4, but it's not adjustable. We could start fiddling with resistor values, but there's absolutely no point. Deviation. Get the little oscillator. Bring that camera back so we can see the deviation meter. And we've got just under 2. Just do a quick whistle test. Wallow. Yep. No, it's not. It's not being fiddled with. Sometimes you get these in with 7.5. You know, it's like transmitting on 3 channels at once. Just give that a quick spray. It was with the service oil switch cleaner. It was a bit reluctant to move smoothly. Wallow. Testing 1 2. Wallow. Wallow. That's it. So that's transmit done. So we'll move on to receive, and we'll set the detector first. So I'm going to put an S9 signal. I have an S9 signal already. Just make sure it's on free. I'll tell you what we haven't done. We haven't done the frequency. So I'll just put on camera 3. So look at the frequency counter. 2779104. It's dropped. Should be 125. So we'll just bring that up. You know, apart from the soldering around that phase lock loop chip, and it turned out to be, of course, a faulty chip, this radio hasn't been fiddled with. So we're back on frequency now. It was within spec. I mean, it was neither here nor there, that, but nevertheless, it's now correct as we want it. So I'll just put the camera onto the oscilloscope, and we'll be looking for maximum received audio. And that oscilloscope's across the speaker terminals. It's nothing clever. So I've just turned the bench light off, so we've got the maximum brightness on the oscilloscope screen. So what we're looking at is to adjust the detector, which is T11. And we've gained some there, and that's important because it can affect the squelch as well as the intelligibility. That's a good word for a Tuesday. So we'll now put the signal down. I'll tell you what, that's 0.3 of a microvolt. And we'll just put the camera now onto the Cybernet meter. So, if you haven't been following these, the reason we're doing Cynad and not other methods is it actually came out really after these radios were made. So it's not in the manual, but it's by far the best to be tuning up on the best possible signal to noise ratio, and it saves a lot of time. So we'll start with, we're going to be doing transformer 5, transformer 6, transformer 7, 8, 9 and 10. And we're looking to get that needle to the left. So you can't hear these differences, and the meter can. So we have gained a bit there. I could also say not a lot. But the fact we've gained anything is a little improvement. There we are, it's done. It's just a tiny little touch on that top coil, and that detector was just that tiny little bit out. So for 38 years, that's brilliant. Right, we'll get some readings now. So we'll start with, for 20 decibel Cynad. For 20 decibel Cynad, it's doing 1.6 microvolts. But the more important ones are 12. It's doing just over 0.6, 0.605 of a microvolt for 12 decibel Cynad, and for 10 decibel Cynad, it's doing 0.505. So very good. Now then, let's set that S meter. So the S meter, and we can lose that camera. Boing. Should be reading S9 for 100 microvolts. 100 microvolts is S9 in the UK on CB radios, not on ham radios, where it's 52 microvolts or 53 or something like that. So it says plus for plus 30, which is a bit too generous. So the preset for that is RV2, which is the meter, which is that one. It's a bit cooler today, so it's not a shorts day. I've put that in for Mr. Radio Cruncher. That brings us to the Squelch. So I'll turn the signal generator off, set the Squelch to threshold, switch the signal generator back on. It's come straight in at 0.3. That's excellent. Now we'll turn the Squelch to full. Now we'll turn the signal generator up. 1 microvolt, 3 microvolts, 10 microvolts, 30 microvolts, 100 microvolts. That's exactly where I want it to come in. It is absolutely perfectly set. If it wasn't, it's the preset there, RV5. Now, I can, over these 38 years doing these, it's not often that hasn't been messed with. That's brilliant. So, thanks Eddie, that's a nice scrap radio which has cost a phase like loop chip, and of course they don't come free, but I was able to get that one off a scrap chassis, and that does keep the cost down, although of course I have to buy the scrap chassis. Well, usually I do, apart from very generous people who sometimes send me them. So, what I now need to do, the radio is now spot on, so I'm just going to pause it and we'll put a meter lamp in. Now, somebody says, what are these meter lamps? They're 40 milliamp at 12 volts, and hopefully we've got some left because they're in short supply at the moment, and Rapid Electronics, where we get them from, they're sold as a grain of wheat lamp. I think there's one up there. I'll tell you what, you can press into service, because when we had a television and audio shop and subsequently videos, we've still got some cassette lamps in stock, and I've been known to put those in when we've run out. I'll go on a search for that, and then I'll put it back on record. So what I've had to do, because we've got caught out as well, I've had to buy these off somebody on eBay, which is Modelling Electronics. modelingelectronics.co.uk, and they're more or less the same lamp. But don't for a minute think they come cheap, because they don't. Oh, and please don't put LEDs in. These are vintage radios. You know, it's like saying, oh, I've got a 1937 Rolls Royce, and then you put Cree LED headlights in it and a CD player, and you think, what on earth's that about? I see these and, oh, it hurts me. Anyway, each to their own. I suppose if it's your radio, you do what you want. So on this radio, it's quite easy to get to. Of course, I've already got the lids off because they're in our dishwasher at the moment. Oops. So on this radio, it's mounted here, just above the meter. Of course, on most radios, it's kind of inside the meter, and that makes this so much easier. And also is less likely to damage a radio. Now I'm going to just snip these wires so I can get this out carefully. Of course, I could always cut through some extra wires for a laugh. I think those cutters are shot it. So it's a plastic holder, and somehow got to get that, because it's melted its way in over the years. There we go. So that's the original one. It's a little bit bigger than our replacement. This could have been a candidate for a video cassette lamp. So ours is going to pop through there like that, then the wiring will disappear down there. I'll put a dab of glue on there just like they did originally at the factory. So let's see where it originally went. Well, that's one of the wires. And that's the other of the wires. So one end of it, quite simply, goes to the on and off switch. So you've got a red wire just there. So we'll put one of these wires on there, and then we'll see where the other one went. So that white wire, which went to all the trouble of pulling it through, actually goes there. So we can just pop that one off. I'm going to desolder that properly, and then we'll apply new solder. So I'll just thread back the white wire. There we go, and hey presto, it's the right brightness and not glaring at you like a car headlight. So that helps when you get the right number of milliamps consumption, which we were able to do. So I'll go to the dishwasher and we'll see what's left of the front and the knobs. So you can see about this knob, it's lost its skirt. So anyone who's got one of those, as I said, I will purchase it. So we'll just zoom out on this camera. Mr. Chippy's actually ready to do a scratchy corner range testy thing with us. And so we'll just finish off this video. Because we have to say 19 a Roger, don't we? 19 a Roger. Right, so there we have it, a Mustang CB2000 from 1981, now back in the land of the living. Thank you for watching.